Hello, in this video, we're going to discuss a system for movie rating prediction.
Our goal is to design and implement a system to predict what someone will rate a movie. For context, this information is useful because it can be used in recommender systems. These systems can not only be used to suggest what movie you should watch next, but also in the context of music or online shopping to recommend songs and products.
Our system consists of three main components: non-negative matrix factorization, or NMF, using expectations to gather user preferences, and making a prediction.
In the NMF step, we begin with tag data, which links each movie to a series of user-defined tags. We perform non-negative matrix factorization on this tag data to break each movie in the dataset down into its component templates, or genres, which represent groups of tags. Our system uses 50 of these genres. This number was chosen to maximize performance without creating a prohibitively long runtime.
In the second step, we use a reviewer's rating history along with a genre breakdown of previously rated movies to determine a reviewer's opinion of each genre. This is done by taking the expectation of the reviewer's known ratings, with each rating given a different weight based on the movie's relevance to the genre in question.
Finally, we can use a query movie's component genres and a query user's opinions of those genres to predict an overall rating.
We tested our algorithm on over 1,000 movies and 200,000 reviews from a movie lens rating dataset, with a 80% training and 20% testing split. To evaluate our system, we used the root mean square error, or RMSE, which is a common metric in collaborative filtering problems. Initially, our RMSE was 0.9748, but the RMSE when we simply predicted the mean was 0.9644.
Hypothesizing that putting more weight on the movie quality might improve our system, we decided to implement a rounding mechanism. Here, if the mean movie rating is higher than our preliminary prediction, we round up to the nearest half star. Otherwise, we round down. After this adjustment, our RMSE was 0.9597. This is a significant improvement. To gain further insight, we will investigate the ways that our system was successful and unsuccessful.
So we looked at a bad prediction where our system predicted 4.5 stars and the reviewer rated the movie zero point 0.5 stars, as well as a good prediction where the system matched the reviewer's rating of 3 stars. From the results, we observed that the least accurate prediction had a wider distribution of genres, and also that the reviewer's prediction was farther from the mean. We can thus partially attribute the inaccuracy in our system to not being able to classify the movie into a primary genre well, and also any other miscellaneous errors, like what if the reviewer was just having a bad day?
A few of the challenges we faced were designing a system and dealing with a large data set. Ultimately, we learned a lot about collaborative filtering and recommender systems, but also that signal processing tools have a wide variety of applications outside the classroom.
Thank you so much for listening to our presentation.